Hello everyone, and welcome to lesson 1.3. Okay, so we're still kind of on chapter 1, or I'm sort of mixing a lot of these chapters, a lot of the information. I feel like this is really the beginning stages of statistics, so don't really follow the book exactly, because I am putting a lot of the I'm just putting a lot of the intro sections in this section and calling this lesson 1, and just a series of lesson 1. So when we go through our lesson 2s and so on and so forth, it'll be, a little bit more a little bit more applicable. But right now we're still kind of going on some of the beginning stages, so I'm gonna go ahead and say this is still part of our lesson 1s, although it's a mixture of some of the various chapters that we have to study from our books. Anyway, let's move on. What is lesson 1 going to be about? Okay, so what we're going to look at in this section, okay, is we're going to go over what are the steps in conducting an actual statistical study, or really a science experiment. Okay, that's mostly what this is. So we'll see where statistics really fits into an actual study and what the steps are going from the beginning of the study to the very end. Okay, basic stuff. All right, then we're going to look at some more basic terms and definitions, and we're going to talk about what bias is, and then we're going to look at different topics in randomization. Okay, so first, and the first part of this section, we're gonna go ahead and look at all the different steps in conducting a statistical study, or just call it a science experiment, whatever you want to call it. We're gonna look at the different steps, okay? Because really, it's very important to follow the different steps. If you skipped anything, you're not really doing it right, and you can miss different things. And when you try to conclude the whole thing in the end, it's just not going to be right, and you might not be able to rely on your results. They may not be significant. Okay, so we got that going, and we're going to look at some more vocabulary terms and some healthcare examples as we figure out the different steps of statistical studies. All right. So here is your basic guidelines in conducting a statistical study, okay, or a science experiment. Okay. So the first step is to state your hypothesis. Okay. I hope you all at this point know what a hypothesis is. Please tell me that you do. Okay. We probably should. I feel like we should have already learned hypothesis, back in 2nd grade or whatever. But if you don't, pretty much a hypothesis, I think they like to call it, or the basic way to describe a hypothesis would be like an educated guess on what you think is going on in this particular phenomenon. Let's say you observe some sort of phenomenon that's happening, you want to do a study about it, you want to figure out what's going on there, or maybe you think there's like a cause and effect happening in that particular study. So what you're going to do is first ask a question, okay, and you're going to answer the question with your hypothesis. All right, so make an educated guess on what you think is happening. All right. Normally, you're going to conduct a whole bunch of research. You're going to read a lot of papers. You're going to figure out. So you're going to actually have a really good idea about what is actually happening before you even start the study. But you do need to take a guess, if you call it that, and just sort of say it like, answer the question, all right? Answer the question that you're asking. That is your hypothesis. Okay, so then after that, the next step is going to be you need to identify the variables of, or the individuals of interest. So what is your study going to be about? Are you doing a study on are you involving like your coworkers? Maybe you work at a healthcare facility, you want to do something that involves your coworkers. Or maybe you just want to do something that involves patients that walk into your clinic or anything like that. So if whatever you're doing, if it's patients that are at your clinic, those are your individuals of interest, right? Maybe it's certain types of patients. Maybe it's patients who come in with a certain disease, okay? Then those particular patients will be your individuals of interest, okay? So then you're going to specify the variables that you want to measure. Okay, so what do you want to measure in this study? What were you trying to figure out? Is it if you're doing a study that has to do with some like a particular disease in certain patients, maybe what you're trying to measure is, well, it could be anything. It could be the severity of the disease. Okay, you're trying to measure that. You could even be measuring how well informed the patients are who have this particular disease. Maybe you want to see, maybe it's a public health thing, you want to just make sure that everyone who has this particular disease knows how to take care of themselves. So you conduct a study to see how well informed the patients are who have this disease are. Okay, so the how informed they are is what you're going to be measuring there. So those are your variables. Okay. Then step 4. All right, so you're going to determine if you want to use the entire population or if you're just going to take a sample. Now, we've already kind of been through this conversation about how it's better to use a sample and you have less resources to deal with. It's going to be cheaper, it's more practical to use a sample. But the thing is, if you have access to an entire population, and if it makes sense in your study to use a whole population, and you have the data, or you can easily get the data, then you may as well just do that. That way it's more precise. But then again, if it does seem like a waste of resources to gather that the entire population data, if it's going to be more expensive, if it's going to involve a lot, it doesn't seem very practical, if it doesn't even seem very necessary, then you do not need to do an entire population. A sample is fine. That is more than fine. Okay, so you kind of just want to choose what you want to do, population or sample, and then you also want to decide what type of sampling method you would suit your study the best. And the previous lesson ones, lesson 1.2 especially, has all the a bunch of different types of sampling methods that you can choose from. So depending on what your study is about, you will choose your sampling method accordingly. Okay. So then number 5, you're going to address any ethical concerns before you start collecting your data. So when you're about to collect your data, sometimes ethical concerns can come up. Like maybe you're asking sensitive information of the individuals of interest, of your sample. So you may want to just make sure that everyone signs like some sort of waiver. Maybe you want to make sure that you are not doing anything too invasive, or if you are, you want to do a little bit of research and make sure that you're not stepping over any boundaries. Okay, and find out what the guidelines or what the rules are for conducting the particular study that you have in mind. Okay, and then go according to that. Usually, when you're doing a study like this, you're going to submit, before you even start collecting your data, you need to submit to a review board, an IRB, or there's another type. But anyway, normally you would submit it to like a review board, and they would check if your study is going to be ethical, if there are any kind of ethical concerns or anything like that. Just to make sure that you're good to go, right? And they'll sign off that it's fine, and then you can go ahead and start collecting data for your study. And if they say no, your methods there's something wrong here, this is going to be too invasive, you need to change this, or if you want to do this, you have to do these steps or whatever, then you just go ahead and fix your study accordingly, and at some point you should get it approved and you will be good to go to collect your data. Okay, so you always, after you figure everything out, you always want to just make sure there are no real ethical concerns. Okay, you don't want to be asking horribly sensitive information and then not be careful with that, and somehow people's private information is, spread about. You also don't want to, what if you are conducting a study where you have test subjects that are maybe trying out a new drug or anything like that. So you gotta make sure that all the ethical concerns are taken care of. Okay, very important. All right, so number 7, you want to use, you're going to use either descriptive or inferential statistics to answer your hypothesis. So this is really the part where what we're learning in this class comes in. Like, this is where you do a lot of your the work that you're learning in this class. Okay. Of course, looking at variables and individuals of interest and what type of sampling you want to do, yes, that's great. But when it comes down to actual data collection and really analyzing the data that you have collected and using, that is the part where you are actually going to be doing the math and organizing your data in such a way where where you get to answer your question. Okay, you get to find out if your hypothesis was on point, if your data supports your hypothesis or if it does not. Okay, so by doing descriptive or inferential statistics, you should be able to answer your hypothesis. Okay. Number 8, in the very end, you're going to go ahead and write everything up. All right, usually you're going to have a report or an article or a book, or you're going to do something. You're going to write up all of this information, of course, because the point of conducting studies is to spread and to provide new information. Okay, so of course, whatever your findings are, they need to be given out so that people can make practical use of your findings. Okay, so you're going to write this up, you're going to provide your analysis, express any of your concerns or any notes, anything that you think may have gone wrong in the study, any mistakes that may have made, anything like that, right? And then you're going to go ahead and make recommendations for future studies as well. Okay, all right, so here's an example. Let's say your hypothesis is going to be air pollution causes asthma in children who live in urban settings. So in this situation, the individuals that you're going to study will be the children in urban settings, okay, your individuals of interest, right? And then the variables that you're going to be measuring in this situation will be air pollution and asthma, okay? So then the next step, prior to actually collecting data, you're going to also need to decide on how you want to collect the data as well, okay? So sometimes you can actually use a government data set of data, okay? Because in some ways, sometimes the government actually has that data already, and it's already confidential. It's just numbers, it's ready for use in such studies, okay? And in this situation, they would have, you know, data for the whole population. So it may actually be good. So if you have access to this kind of thing, it might actually work for you. But in many cases, that's not going to be the case. You won't be able to use government data, or it just doesn't suit what you're doing. So you may need to collect a sample. And so when you collect sample, of course, you're going to need to choose your sampling approach. You're going to need to know if you legally have to have consent from the people that you're collecting the data from. And you're going to need to know if there are any kind of ethical concerns that you should be aware of while you're collecting the data, especially in this study that we're using as an example, because we're studying the children. So do you need parental consent for the data? So an IRB, all right, this is one of those review boards that I was talking about in the previous slide. Now the IRB is going to definitely come in handy. Okay, you're gonna go through this when you have a study that you want to conduct and you want to start collecting data for this, and you're definitely not using government data sets. All right, so if you were using a government data set, that kind of bypasses the need for an IRB, because you're using already collected data that is totally confidential. None of this information is sensitive at all, and there's really no risk. Okay, so there's no risk. There's no risk of you accidentally, not being careful with someone's personal information and having it spread everywhere. There's no risk of you doing, something illegal when you were given this information by the government to use for your study. So you're good there. But if you're doing it if you're collecting your own data sample and doing it on your own like that, you definitely need to go through an IRB, or a review board, an internal review board. And usually in most universities, they always have their own review board. Okay, so that makes it really convenient, and cheap. Okay, if you were going to conduct your own study and you wanted to do this separate from the university, it would cost so much money. Okay, I'm just letting you guys know that going through an IRB, a private IRB, is going to cost a ton of money. Anyway, let's move on. Okay, so now we're kind of at that point. Do you want to use census? Do you want to use a sample? And I know we've kind of discussed this so many times before, but I just want to give you guys like a good visual of what it means to do census versus sample. Okay, so you can make a better decision on what you need to do for your particular study whenever you do a study. All right, so in a census, measurements or observations from the entire population are used. Okay, so if we use an example of a chessboard, it would be taking like all of measurements from every single population. So all of these pieces who are part of the population on the chessboard, that you would be collecting data from every single one. Okay, but in a sample, measurements or observations from part of the population are used. So only part, like let's say we only took part of it, one sample, and use that. So this would be a good representation of what a sample is like. So it's just a little bit of the population that you took measurements or observations from, right? And as you can see, these are all different pieces. So it's kind of a good sample. You want to make sure you get a little bit of everything, because the thing is, you want your sample to be a representation of the population. Okay. Okay, so let's look at the different types of studies. Okay, so they're not all the same. All right, there are two main types of studies, or two main categories, if you will, different types of studies that you could really be conducting. Okay, so first will be an experiment, and then next we'll look at observational study. So an experimental study is a treatment or intervention that is deliberately assigned to the individuals. Okay, the purpose of this study is to study the possible effect of the treatment or intervention on the variables that are measured. Okay, so basically in an experiment is when the researcher, okay, asks or has the individuals in the study do something, all right, and then you study the effects of that. Okay, for example, it could be a study where you have people take a pill, and then you're going to study what the pill does to them. Okay, or maybe some people will take the pill, some people will take the placebo pill, and you're not going to tell them which is which, and then you're just going to study the effects of what happened in that study. So that would be an experimental study. You are conducting like some sort of intervention, okay, or a treatment. You're getting your individuals in your study to do something, all right, and you're studying the effects of that. That's the most basic way I can explain an experiment. Now let's look at observational. So an observational study, this is where observations and measurements of the individuals are taken and no treatment or intervention is happening. Okay, so the researcher does not say, hey, all you test subjects, do this so that I can measure you. That does not happen in an observational study. Basically, all that happens is the researcher is going to take measurements or just observe the individuals, and that's it. They're not asked to do anything different. Just go about your day as normal, or just do what you would do, and nothing different. The researcher will observe or take measurements. That's it. Okay. Okay, so I wanted to give you guys some examples about what an experimental study is and then what an observational study is. So for the experimental study portion of this slide, we will look at what they did with the Women's Health Initiative a while back, a long time ago. So the thing here was that what they did was they wanted to do an experimental study design where they provide women, like menopausal women, with hormonal therapy, and then they could see what the effects are of that. Okay, and the thing is that during the time they were thinking, well, this hormonal therapy we think really works for the, to help women during this transition period, but also the hormonal therapy might give them cancer. So what they did was they wanted to set up a whole experiment to do on the women who are having this therapy and, figure out what's going on with them. This would be an example of an experimental study. What they did actually, they did experimental, but also with an observational study on the side. So for all the women who actually did not qualify to be part of the experimental design, they decided that they're still going to study them, but they're just going to observe them. Okay, so they were just part of an observational study design. So they did kind of both with that. But the purpose in the beginning was just to do the experimental study design to kind of see what is going on with this hormonal therapy that they're providing women, menopausal women. Okay, now let's look at the observational study. All right, so observational study, the example we have is the Nurses' Health Study. Okay, so this one right here. The thing is that a while back they realized that nurses, they're very smart people, and they are really good at paying attention to their own health, the health around everyone else, and they're also really good at documenting and surveying. Okay, so what they decided was that, you know what, we are going to survey nurses every 2 years and just have them talk, report on what's going on with their health. So they're able to track that kind of thing. And that just given that they're only collecting data, just a survey, an observation of what's going on with the nurse's health. That is just an observational study. They're just taking measurements or collecting measurements. Okay, they're not asking them to do anything specific. They're not trying to measure like an outcome after they get them to do one thing or anything like that, as with an experimental study. So the experimental study with the Women's Health Initiative, they had the women who were part of that study take the hormonal therapy, and then they measured the outcomes. Okay, in an observational study, you just straight up measure and observe. That's all they're doing. Okay. Okay, so replication. So the thing is that what you really need to know, a huge thing that I want to stress about conducting studies and things like that, is that in science, all right, we can really only accept something as true is if it has been able to have been replicated over and over, and we always get the same results. So clearly, this must be the truth, okay, because it's always true, it seems like. All right, so that's how science moves forward. That's how we start accepting new truths, and we move on from there. All right. So in order for something to be able to be replicated, is that these studies must be done rigorously enough to be replicated. Rigorously. And what they mean by rigorously is you have to be very careful. Make sure that you dot your I's, cross your T's, do everything perfectly according to the book, down to the T throughout your experiment. And you need to make sure you're documenting everything and it's all like just so well enough that if someone else were to redo your experiment or your study, they would be able to just do everything that you did and get the same result. Okay, so if other researchers are able to do your study, follow all your steps, do everything you did, make sure that your sample size is appropriate, the methods you use to collect your sample and the data is appropriate for your experimental design, make sure that you're doing everything correctly, then you should always be able to come up with the same results if it's true. Okay, so if this is a new truth that we all have to accept, well, it has to be replicated. It has to be replicable. Okay, so that's why we have to make sure that we conduct our studies rigorously enough so that it can be replicated. This goes back to just making sure that you are reviewing everything, okay, and making sure that you're doing everything appropriately for your study, okay? So now let's talk about bias. So when you're doing your experimental design, or even when you're just conducting a survey, whether it's for an experimental study or for an observational study, it really doesn't matter. The thing is, you always want to be taking steps to avoid bias. Okay. Surveys can provide so much useful information, but the thing is, if you're not mindful about bias that can just creep up, then they can creep up. And you do not want to you don't want to be in a situation where you look back and you look at your data and you go, oh no, I think that this is not consistent, this isn't where it should be. There may have been some sort of, there could be bias here. This might not be a good representation of the entire population. This might not be what exactly is happening to the population. So there are several considerations that you should be making when you're doing your study just to avoid bias.